Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus KPK Book Foundation Physics SSC to Unit number 13 Electrostatic. Today we will solve SLO base according to FBISC requirement numerical problem question number 7 to 9 in part 3. So let's start the today lesson numerical problem question number 7. In question number 7, given statement, determine the magnitude of electric force on the electron of hydrogen atom exerted by the single proton, that is, the atom's nucleus is assumed that the average distance between the electron and the proton is R is equal to 5.3 multiplied by 10 raised to power minus 11 meter, and charge on electron and proton is 1.6 multiplied by 10 raised to power minus 19 coulomb. So, according to the statement, write the given data. Charge on electron is equal to Q1, that is equal to 1.6 multiplied by 10 raised to power minus 19 coulomb, and charge on proton Q2 is equal to 1.6 multiplied by 10 raised to power minus 19 coulomb. Now, the distance between electron and proton R is equal to 5.3 multiplied by 10 raised to power minus 11 meter. Coulomb constant K is equal to 9 multiplied by 10 raised to power 9 Newton meter square per coulomb square. Now, required that the magnitude of electric force Fe is equal to question mark, and we can find the solution using the formula electric force Fe is equal to Kq1 Q2 upon R square. According to the Coulomb's law, F is equal to K Q1 Q2 upon R square. So, magnitude of electric force Fe is equal to K Q1 Q2 upon R square. Putting the values, then 9 multiplied by 10 raised to power 9, 1.6 multiplied by 10 raised to power minus 19 multiplied by 1.6 multiplied by 10 raised to power minus 19 divided by 5.3 multiplied by 10 raised to power minus 11 whole square. Now calculate the value. We can find the magnitude of electric force Fe is equal to 8.2 multiplied by 10 raised to power minus 8 Newton. Now we will move the next numerical problem, question number 8. In question number 8, a 5 microcoulomb point charge is placed 20 centimeter from a 10 microcoulomb point charge. Now we can find in A part, calculate the force experienced by 5 microcoulomb. In B part, what is the force on 10 microcoulomb charge? Now in C part, what is the field strength of 20 centimeter from 10 coulomb point charge? Now, given data Q1 is equal to 5 microcoulomb and charge Q2 is equal to 10 microcoulomb. The radius r is equal to 20 centimeter. Change the centimeter into meter. Then r is equal to 20 divided by 100. That is equal to 0.2 meter. Coulomb constant K is equal to 9 multiplied by 10 raised to power minus 9 Newton meter square per coulomb square. Now we can require that electric force on a charge 5 microcoulomb, that is equal to Fe is equal to question mark. And in B part, electric force on charge 10 macrocoulomb, that is equal to Fe is equal to question mark. And in C part, electric field E is equal to question mark. Now, we can find the solution in A part, electric force on a charge 5 microcoulomb. So, we using the formula, we know that Fe is equal to K Q1 Q2 upon R square. That is equal to 9 multiplied by 10 raised to power 9 multiplied by 5 multiplied by 10 raised to power minus 6 multiplied by 10 multiplied by 10 raised to power minus 6 upon 0.2 whole square. So calculate the value, then Fe is equal to 11.25 Newton. Now, in B part, given that electric force on charge 10 macrocoulomb, then we know that Fe is equal to K Q1 Q2 upon R square. That this is a similar answer. Fe is equal to 11.25 Newton. Now, in C part, we will move that electric field strength. In electric field strength, E is equal to Fe over Q1. That is equal to 11.25 divided by 5 multiplied by 10 raised to power minus 6. That is equal to 2.25 multiplied by 10 raised to power 6. So the electric field strength is 2.25 multiplied by 10 raised to power 6. Now electric field strength E is equal to 2.25 micronewton per coulomb. So 10 raised to power 6 is mega m Newton per coulomb. So let's move last numerical problem, question number 9. In question number 9, given statement, in a certain region of space, a uniform electric field has a magnitude of 4.60 multiplied by 10 raised to power 4. Here 4.60 multiplied by 10 raised to power 4 Newton per coulomb, and the point on the positive x-axis direction. Find the magnitude and direction of force this field exerts on the charge. In A part is 2.80 microcoulomb and in B part minus 9.30 microcoulomb. Now, according to the given statement, write the given data. Magnitude of electric field E is equal to 4.60 multiplied by 10 raised to power 4 Newton per coulomb, and required that the magnitude and direction of force exerted on Q1 is equal to Fe is equal to question mark. And also in B part, magnitude and direction of force exerted on Q2, that is equal to F, that is equal to question mark. Now, solution of first part, magnitude and direction of force on Q1, that is equal to Fe is equal to E multiplied by Q1. that is equal to 4.60 multiplied by 10 raised to power 4 multiplied by 2.80 multiplied by 10 raised to power minus 6. That is equal to 0.129 Newton. And in B part, magnitude and direction of force on Q2, we know that Fe is equal to QE multiplied by Q2, that is equal to 4.60 multiplied by 10 raised to power 4 multiplied by minus 9.30 multiplied by 10 raised to power minus 6. That is equal to 0.428 Newton. Best of luck. Remaining videos or subscribe our channel. Best of luck. Allah Hafiz.